Okay, guys, it's about time and let's get started. So, welcome who are here for today's event. Today we're gonna talk about we're gonna talk about context manager, which is a very exciting feature in Python. And probably in 1 hour, when you're done with the event, you will have better understanding around context manager, the with statement that you see in the Python, and just a better understanding around how you can use context manager to write a better code. My name is Nissan Gandhi, and I'm a software engineer at a Data Robot, and uh, I write Python code for my living. And this is the meetup group that I organize for, just be in a community and share the knowledge that I have, and also bring in people together to talk about Python and stuff. Okay, so let's get started. So let's see in today's menu what we're gonna do today. Okay. Yes. So we'll of course start with introduction. We'll talk about what is context manager and how to use them and what is the purpose of their existence. We'll see some code example to better understand what context managers look like, and then we'll try to create some of our own context manager. We do have some demos, so we're going to talk about how to writing your custom context manager, and then a couple of other examples, and then we'll do some conclusion, and then I have references that I use for creating these presentations. So let's first talk about context manager and where it started. So those who know PEEP, which is a Python enhancement proposals. So the way Python language evolves is it's a community project, and different people come together with different ideas on different features that they want to implement in Python. And the way to manage all these proposals of enhancement in Python, they are they're maintained by something called this PEP, Python Enhancement Proposal. It's more like a Jira, if you know how to use Jira. Uh, More of a task or a proposal management tool where people come together, write the proposal and ideas, and then and then finally at the end, if there is a consensus that this feature makes sense, and it's good and everything is going well, then finally it's being implemented for next release. And uh, up until 2018, the Python language inventor uh, Gadowan, he had the veto power on deciding which feature to get let in and let out. And I don't remember who is right now, but Gadowan stepped down, I think in 2018. Until that time, he had like a veto power or final say around what feature gets into Python, what not. And the proposal about with statement or context manager came, I think, with 310, and there are a couple of proposals previously being done, and but the final proposal that was accepted and finally implemented was PEP 343, which talks about with statement. So let's just go online, and this is always interesting to see all these proposals. So this is the PEP 343, and author's status final created in 2005, and Python version. So this is effective since Python 2.5, and since then it is being available. And then you can see specifications, use case, introduction, why you want that. They say the reference about the previous PEP that were proposed around what it has to be, and like how you want to do like reliable acquisition release pairs. So more like you want to acquire the resource and release the resource, so how you can do it reliably. And so that was 310. And then synchronous asynchronous block, that was 319, and both has very much overlapping, and they finally came up with 340 and 343, which is like the final versions of what we see as a with statement. And a lot of other examples are here. We'll go through all these things in our presentation, but just like give you an idea that if you wanna figure out where it all started, and what is the how it all originated, what was the initial conversation around this feature, you can look up this PEP 343, and then you will know about the idea behind the context manager. So let's go back to our presentation. So what is context manager, and what exactly it is designed for? So it is a way to allocate and release resources properly or gracefully, or making it in such a way that are less error prone. So if you use the context manager to allocate the resource and release the resource in your Python program, and what I mean by resources, your file could be a resource, a database connection can be a resource, a memory block can be a resource, or there's so many other things which you can consider as a resource. And APIs could be resource, where there's a way to allocate and deallocate. So it always comes. So a lot of times these resources, when you acquire the resource, you also have to release the resource. Otherwise, it may cause a problem. And uh, you know, uh, if you use the context manager, you can really not get into this trap of acquiring resources, but because some error occurred and you couldn't really get to execute the block which actually release the resources, and created this issue that the resource connection is open and it's too much open, and that is causing a lot of other challenges and other problems. So it is better than doing try exception finally. So you will see that in a lot of places, like, hey, try to open database connection. If doesn't, then do something, and finally close the database connection. So a lot of time what happens that for some reason you open the database connection, and then connection is open, and then down the line something goes wrong, and then you don't get to close the connection for some reason. Maybe your program crashed or something like that, and that will keep that connection open from the server side. And a lot of times this kind of scenarios occurs. Normally what we do is, in the try you open the connection, then all the code, and in finally you write the close that connection. So within the execution block, if something goes wrong and something fails, then in the in that finally code block, it will go there and release all the resources. And this can work. And I'm not saying that that context manager are they are trying to solve the problem that previously existed but no one solved. So this issue of releasing the resources when something goes wrong is, you can do that using finally, but context manager is much more better way and much more easy way to do that. Now, how you can implement context manager? So basically, there are two methods: class and generators. So you can write the context manager class and work with that, or you can create this generator. And we'll look into both of these. This case, both can achieve what you want to achieve, but based on your scenario. And sometimes generator can come out as a much more cleaner or simple looking solution. So people use generator a lot than classes, but classes and generator, there are two ways you can actually write your context manager. Uh, so let's get into, let's look at the code and understand what is going on here. So this is a simple example. And the first part, you can see this with statement. So with, this is very common code block that you might have seen, where you are trying to open the file and try to write the file. And really there are two ways you can see you can do that. You can just say, file equal to open, the example that you can see below, file equal to open the file in write mode. And then let's say this file was opened properly, then things will go fine and you can do the file.write. And if something goes wrong, then that may create an exception. So in that case, if something goes wrong, you may want to close the resource, because when you're acquiring a resource, right now here it's a file. When you open the file, no other program can access the file because there's a lock on the file. So you want to really go to file.close part every time when you open the file. And here you can see that, so we are trying to so there is a try and finally block here. So in a way that if you open the file and something goes wrong, still because of this try and finally block, you can finally, if something goes wrong, you can come to finally block and clear up the resources calling file.close method here. And if you don't want to use this try and finally kind of thing, what you can do is you can use something very simple. You can use context manager, and using the with statement, the scenario that you can see on the like the first code block, which says that with open, then file name, then comma mode as open file, and open file.write. Now if you see here, what you're trying to do here. So basically the code block that you want to actually execute is this file.write. So this file.write is something that we are trying to do, which is our main code, or which could be the code block that we want to execute at the end. And with, after with, here you're trying to open the resource, allocate the resource, and then get the pointer here. So with open, then you're passing this parameters. So try to acquire the resource, and then there is a there's a more of a handle that you have here that you can use to execute the thing further, which is something similar like that. Here with the file, you are acquiring the handle for this place where you're trying to acquire the resource. Once you have a handle, you try to execute the code using that handle and try and finally. So if you can see here, what we are trying to achieve here with the with is a very neat way to cover your code within try and finally. So you don't have to write the finally here. The open itself do that. So how this whole magical things happen? Why just writing the with method and this some fancy syntax it happens here? So under the hood, something is going on here. When you say with and open, under the hood, some other code is being executed, and that is taking care of this file.close. So basically, when you write with open as file open, so when you are inside the with statement, if something goes wrong, internally this file.close method will be called before you release the resources. Here you are manually saying that file.close. You are not saying here file.close. But once you are done with this with block, it will automatically close your file by calling file.close internally. Now this with and open are provided automatically. So this context manager is available out of the box. You don't have to write open or something here. So this, when you say with open, so this open is a context manager, and this is provided out of the box here. And it is getting a bit confusing because there is an open here. This is a context manager. This is a statement. Both are same. Both has the same name, but here this is a context manager, which handle the resource here in a way that when you open the file and when you close the file, you don't have to mention that. Within the block, if something goes wrong, even though you don't mention file.close, it will when you use this kind of with statement, it will automatically close the file. Now this might look a bit confusing, but I think everything will get clear in the next slide. So this was the example. This is what you have seen, context manager using with statement. Now let's see how the whole thing works. When you see this code, you will understand what is going on here, and you will be able to put the parallels here and understand how things are. So basically, context manager can be done using class and generator, and we'll just take an example as class. Now within the class, when you are trying to write the context manager, so it's a normal class, and this normal class has special methods. Two are special methods, enter and exit. So any class which has enter and exit can work as a context manager. And what basically enter and exit does, as it makes sense, that when you initialize context manager, it will go into enter, do all these resources, resource allocation, and when you finish your whole context manager block, it will execute the exit method. Now exit method will also be called when something goes wrong. So there are two ways this exit method can called. So here's the example with context manager and as, and similar to this, like with context manager as and handle, with context manager as and handle, and then there's a code block here. So this code block will be executed, and once this code block is done, this exit method will be called. Or if this code block cause an error, something goes wrong here, still the exit method will be called. So the way context method work is when you say with context manager an argument, it first do initialization, because you can do the initialization, and then it go and enter into this enter method. So with initialization and then go into enter, and then inside the enter method you can return the handle, and whatever handle you return using this inside the enter method will be picked up using as. So we'll see one example, so you'll have better understanding but what is going on here. But just to tell that when you say with context manager and then pass the argument, this will do the initialization, and then you write as, and then you write some kind of variable name here, and that variable name will actually be the return statement that is coming out of enter. And finally you work with all these things, and finally once you're out of this with block, the exit will be called automatically, and then in the exit you normally do the resource release and stuff like that. So in the enter block, you normally allocate the resource. In exit block, you normally release the resource. So this allocating and releasing the resources happen automatically without you telling to do it, basically. So let's say you want to make a database connection. you can say like class, my database session, something like that. Inside the enter statement, you actually open the database connection and then you return the session of the database connection. And then in the exit, you close the database connection. And when you come here, you can just do that with my, context manager database session as session. You run your queries and that's all. You don't have to worry about closing the connection because connection is being open and closed by context manager. You don't have to do manually. You just say with my database context manager as my connection handler, and then you do whatever you want to do, query, create, commit, everything. And once you're done with that, you just go away and you don't have to worry about opening or closing connection, because opening a database connection, closing a database connection can happen into enter and exit method automatically. So this is how it works basically. Now things will get much more clear when I show you this example. So now what we are trying to do here is we are trying to create a context manager for the file. What we want to do is we want to open the file using context manager, so we don't have to worry about closing the file, ever worry about closing the file, because when you open the file you have to close the file, otherwise things can go wrong, and your resource will be locked and no one else can open the file. So how we do that? Now this is something very similar to what open actually does, like internally, but just to give an example. So what we are doing here, what our main objective is? Our main objective is we want to do some file operation. As example, we want to do some write operation on the file, but we don't want to worry about opening and closing file. We want our context manager to handle all the opening and closing file. All we want to do is just want to use the resource. We don't want to open the resource, open or allocate the resource. We don't want to like close or release the resource. All we want to do is just use the resource and don't worry about opening, closing, allocating, or releasing the resource. So how that works? So we want our context manager to make sure of all this opening, closing, opening or closing your resources, that kind of all this operation we want our context manager to do. So all we can do is just use the context manager and just use the resource without worrying about closing or opening them. So how that works? So first thing, as I told you, that if you want to use context manager, if you want to create your own context manager with the class, you have to define two main method, enter and exit. Enter is about when I'm defining, enter is about allocating the context, allocating the resource, and exit is about releasing the resource. And you can have init. Init is like any other Python class, you can have init method, which is a constructor, and you can pass things and you can use them. It's something good to have. So here what we are trying to do here is, first let's create our context manager file access class, then write init method. Init method will take the file name and take the mode, like read or write mode, or whatever mode you want to open your file with, and then just store them into variables. So this is just like creating two variables, file name and mode, a class variables using these constructor parameters. So now we have that settled. Now we want to outsource our opening and closing task to context manager. So opening the resource goes into this __ enter class. So I'm just going to call it enter. So inside the enter, what do you open the class and then you return the handle, and then in the exit you close the class, you close the file handler. Now when you do return self f, or whatever you return inside the enter method, optional you can do the return, and when you do return you can actually capture this particular handler or particular variable using as. So with cm file name comma v, so here because the constructor, the file name and mode will be captured, and then it automatically also execute the enter method. So init and then directly enter. Inside the enter, it use the file name and mode to open the file handler, and once it's open the file handler, it just return self.f. Now this self.f will be captured by here as f, and then you can finally do f.write, and you finally do the writing, and you don't have to worry about opening and closing because this exit method will take care of the closing. So this was the example of handling the file using context manager and not worrying about opening or closing. Now let's talk about a generator, how we can create the generator to do that. Now if you remember, one of the basic concept of generator, when you're writing a generator, you provide something called yield. This keyword yield, so what it does, yield keyword, so when you're working the generator, you basically are asking for next object using next method. So let's say you create this custom generator, then you say next, or some other way to invoke the next object or next resource or next file or something like that. And yield is basically stop and give you the resource, and then when you say next again, then it will give you next resource. So it's a generator, so it generates item one by one as you ask them. So yield is the place where it stops and give you whatever you want, and then when you next time call it again, then it will give you the next resource again. So okay, coming back to context manager, how you can write a method, uh, how you can write a method, a generator method that can give you that can act as a context manager. So first thing, we need to import something called context manager. So we have something called context lib. So inside the context lib, you can call context manager. So context lib dot context manager, that will get you context manager. This is the decorator that you do import first for making any method a context manager method. And then there are basically 4 part of it. First part is within this whatever method, you first allocate the resource. So if you are opening a file, that kind of syntax, or opening a database, that kind of syntax, just go directly here. Then inside the try, you yield the resource. So let's say in our example, we had this file f opening up here. So similarly what we can do is we can yield self.f. So you are yielding that particular resource for this generator. Inside the finally, you say f.close. And this work almost similarly, just a bit of change. So whatever you write inside this enter method, init and enter method, that you write here. Look at the resource. Except that when you try to return something here, so whatever you try to return here, you write inside a try and yield. So this whatever you are returning here, this particular self.f will come inside the try and next to the yield. And whatever you write into exit method, that way you can write in finally. So that is the parallel between how to create the class and generator. And finally, using the context manager, same as how you're using here. So instead of CM file access, now we have my generator and then resources, and then whatever you yield here will come here as a resource variable, and then you can execute, and then you can play with them and do whatever you want to do, f.write, f.read, or any other code. So here's the example, just similar to CM file access. Remember, as I told you, that when you are trying to do the generator, you need context manager, and that comes from context lib. So context lib, using context lib, we are importing context manager. And so whatever generator class you're making for our context manager, we're just gonna decorate that using context manager. And once that is done, and then next thing is how you want to use that. So if you want to pass some kind of parameters that you can pass directly here, def your context manager and the parameter that you want to pass, and then finally use those parameters to use either way to create the resources here. Now once you have allocated the resources here inside the try and yield, you kind of like yield the resource, or so this is the place where whatever you yield, that will be captured by as, and whatever variable you pass here. So yield xyz as pqr. So your xyz will get into this pqr. Then you can use pqr to do rest of stuff. And finally, inside the final block, you read f.close. So when you say with CM access, open the file as f and f.write, you don't have to worry about how to open the file, how to close the file, because that has been taken care by context manager. All you have to worry about is use the context manager and use the resource. That's all. You don't worry about opening and closing. You just use the resource and use context manager both together, and that will do the trick. Sometimes what happens is some people start writing some code, long piece of code, and they forget to do the f.close, and that can cause real problems. So this is I think at this point I'm gonna tell the real story. Back in days 2015, I was in college, and we had this technical festival, and we made this website which was more like a treasure hunt website, where you go online, find the treasure, and find this, we used to call it capture the flag. So flag is basically some kind of string. So basically it was a quiz kind of place, where in every quiz you go online, you start quiz 1, you find the answer, you get the answer from internet. If you're successful, you go to quiz 2. Now all the backend stuff that to operate this quiz website, we had using Microsoft, MySQL server in backend. So MySQL in backend, and in the front end we had a PHP at the time. And what we did, the mistake that we made was, in so many places, we were in college students, we never worked in industry, so it was more like uh, first time we are trying to open up an application to simultaneous 200 to 300 people. It was a technical festival, and all the students were participating in this event where this website that we built, they were going to use that website. And as soon as we started the event, suddenly everyone's page started getting crashed. So people were like calling us, hey, like your website is not working, it's crashing, it is showing that too many files are open, as an error message from MySQL erroring, saying that your file descriptor saying that too many files are open for MySQL. And then we looked up online, and then we kind of like figured, oh, we need to increase the number of connection, that number of threads that MySQL open up, because every time your database try to talk to your application, try to talk to database, it open up the thread, a pool, a kind of channel to talk to your application. So let's say there are 200 people simultaneously trying to access MySQL. So there are 200 threads being open in MySQL to handle each of them. And this is something configurable. So inside the MySQL, you can say that, hey, I want the capability to open 2000 thread at a time, but it's a balance, because if you open up too much thread, it will slow down your system. But the thing was, there are some default settings and default MySQL connections, and it was not one user, one connection, because we were opening connection multiple times. We were opening up connection when they were logging in. We were opening up connection when they try to look up their scoreboard. We were opening up connection. There's so many places where we are looking into database. Every place we are opening new connection, and we are not closing the connection at all. And there's so many open connection at the time, and it all like crashed down. And at that time, I mean, we could not go to each and every place in the code base and write this like, file.close, because it was kind of like a fairly large code base, something that you cannot modify, let's say in 2, 3, or 5 minutes. It was like, and even to understand the problem, it took some time. So it was really bad. Like it's a war story that, like when you're dealing with all kind of resources, and simultaneous resource users increase, you have to close the resources, you have to close the connections. If you don't, things will start crashing, because there's just so much resources that your system can handle. There's just so much database connections that your application can open up with your database. There's just so much connection that your database software can talk to the file system, because at the end, your database MySQL is also storing some kind of data into your file system, that is loading and connecting. So there is all this kind of interface going on. And if you don't close those connections on time, it will like, it's really hard. I mean, this is really stupid mistake, but it happens sometimes. And let's say, I'm not saying that you guys gonna make mistake and like, open up the connection and never close connection. But let's say there are a couple of places where you forgot to make the connection closed, and then your application go online, and it's working at the most of places, but just a couple of places, the connection is not closed. And it can go bizarre, like it's gonna go crazy. So it's always good idea that you don't have to worry about doing that, making that check. You can have this one place, one part where it open connection, close connection, give you just resource to use, so you don't make that mistake. So that's how it make code your error prone, because you have this kind of a code block that it does that. Now I'm not saying that context manager is the only way to do that. You can have a wrapper classes that like when I didn't knew about context manager, I start writing these wrapper classes where every time you want to get the database connection, you don't open direct connection, you go to this wrapper class, and that wrapper class will make sure that you open and close connection when you're something similarly what context manager do here, something similar kind of implementation, but separately and not using context manager. But the idea is the context manager is much more cleaner, neat, and native Python way to do those things. So it's always useful to do that. So that's why that's why this statement is very useful. And there are so many other hacks you can do. Technically, when you are using context manager, there's an enter and exit method, and you can imagine what you can do, for particular code block. Like I want to do something before this code block start and after this code block end, and you can do everything that with that. So here we are trying to manage the resource before operating in this small code block, but you can do all kind of thing. You can even do logging before. You can say with my logger something as whatever, and then you start working on something. And so every time you go into this code block, there will be a custom, this context manager will execute this start and end, and write to the method. So there's so many things that you can do with that, and we'll see a couple of examples ahead. So now let's go to the demo. So all this method that we showcased you right now, we're just going to go and demo all of them and kind of just run them and see how it comes out. Okay, so here. So first thing, let me zoom in. Okay, cool. So this is, we are very used to this example, with open statement, you want to open up the file. And so let's just do that. Okay, now we need to see where this particular file is. Just give me a sec. So what I'm trying to do is, because it's a file open close method, we need to look at the file system. So here it is. Let me delete all these things so it becomes clearer. Okay, cool. So this is where we are trying to like create a file with open file, simple. This is a typical code that you will normally execute, and you can see in my file, it says that this is pip meetup. And now let's go and look at the next statement. So this line and this line both are similar. Basically, technically, that you are trying to open the file. There's a try that is finally we'll close the resources here. And here you don't have to close the resource. It just closes automatically. So let's just do one thing. Print. So it says the file is closed, right? And let's just try to do this same thing here. Print F, file is closed. Now just for the fun part, let's just not close the file and then we run it. So this is a file open, right? So here we can see that because of this finally code, we are able to close the file, but here we don't need to write anything. It just automatically closes the file. And this is something that is coming out of the box. And we don't need to do all this. When you're using with statement, you don't have to write your own context manager to close the file, because closing the file with the with is out of the box Python feature. But if you want to do something custom, you have to define your own context manager. So now let's look at this example. So what you're trying to do here. Similar as we talked about, we are trying to define a context manager. There's an init method, enter and exit method. Inside the init, we are passing the file name and mode to just initializing these variables. And enter will also be called. And with this F, whatever you written here, self.f, that will come here as an F, and then you can use F to like do things. Now, if you want to see, we can do a little bit of print statement just to see, like, inside enter, inside exit. So, it's just go inside enter and exit, and like, you don't have to worry about them. Now look at context manager with open and close. So now here, what we're trying to do is we are trying to create a context manager here. So context lib is the library that you have to import. It comes out of the box. You don't have to install this context lib anywhere. It's just inside the Python itself. So it comes bundled. You don't have to install context lib library separately. And so here you have this method. Sorry, like as a Python guy, you should not use camel case. It's a snake case here, but just for the parallel, I just use that. So it's fine. Don't hunt me down. So here it's so previously this is the class. So because of that we had a class. Now this is the method. So we have method. We are decorating this with a context manager, file name mode. So f.open, and we are doing the yield here. So when you do yield, this is because of this. This is what define it as a generator, because in the generator you use yield method to kind of like get the resource and kind of stop there until you come back or until you are done. And then you continue with the next method. So when you do this, it basically, okay, sorry, that was, I had to execute this one. So basically it does the yield method, yield F. Now what if, so what if you don't want to, you don't want yield? there are some examples where you don't want to like, let's say yield something. You just want is a wrapper that, hey, within this with statement, when I do with, do this particular, open this environment, and then I will do my stuff and close the environment without worrying about, I don't want to use any, I don't need any resources here, like here is F. How can I do that? So there is an example that will demonstrate that feature. Let's look at this. So this is the example where we want to use, context manager to basically keep track of time. There are so many examples that you can work with. This is one fun example. So here, what we are trying to do here is that we have this method called foo, and we want to measure the execution time of foo by running this under context manager. So here this foo, which is basically create the list of this humongous list, and let's just try to do that. So import, this is the lift. And so here, what without context manager, what we're trying to do here is just start time, get the delta, run foo in between, and get the delta to see that how much time it consumed to execute this method successfully. So this is fairly resource intensive method. We are running through the huge loop. So it says that this is the amount of second that it took for delta to execute. But if you can see here, the code block that you wrote, it kind of looked very messy, like because there is a start time, there's a delta, there's a foo, and then you are trying to measure the time, and it kind of like very clumsy. Instead of that, what you can do is that you can write a context manager, which basically measure the time for you and print the time for you. So how are we going to do that? So as I told you, what context manager basically does, what context manager does is you want to execute some kind of code block. So you can wrap that code block around this context manager, which will execute something before and something after you are done with processing the code block. So how it works? So we want to execute foo. So you can do something like with execution time foo. This execution time is our context manager here, and then you run the foo. And then there is something that you want to run before foo and after foo using context manager. Here you're running this before and this after foo to print, and and printing the time to run the foo. So when you say with context manager, so this is a wrap. This act as a wrapper on top of this method, which will wrap around this method. So what you're trying to do here? So context manager, execution time, so start time. So this is the method that it go before foo. So if you remember in context manager, yield is the part where it kind of break down before executing this block in the with and after it. So everything that before yield will be executed before this foo or before this whole code block and inside the with, and everything after yield will be executed after you execute the with block. And here we don't need any a handler here, because there is, so here we needed handler because we had to work with the file, but here we don't need any handler here. In this use case, all our context manager is doing is wrapping our foo method with some time thing. So start, yield, and print the delta. So now this look very, very neat and clean if you think about it. Like there is no funny thing going on here. It's easy to read with execution time. You know what execution time is, and then there's a method foo, and it just worked perfectly fine. Instead of this, which looks slightly clumsy, and so many things going on here, this is like very nice and smooth, and very simple to read and easy to understand, and looks very easy. And although there's a bit of a code that you write for execution time, but think about that. Let's say if you're writing a code which has where so many places you have to like measure the time for certain method to run, instead of wrapping every time between this start and end, you can really create some kind of context manager and just call the method through the context manager and use that. So this is why it's very important. So just to recap, so the first thing, there are two methods that we saw today. One was using the class, where you define the class, you define enter and exit method, and then every time you call this particular class and as an F, so this first line, at the end of this first line, everything inside the enter will be executed, and whatever return statement is returning, this self-help, whatever the return will be there, will be captured by this variable after as. And so once you're done with this statement, then you go inside the code block and you all kind of statement here, XYZ, and once you are done with this whole code block, and once you arrive here at this point, when you are at this point, it start executing the exit method. So once you're outside this with block, once you're outside this with block, once you come out outside, the exit block will be executed. And it doesn't matter if there is an error or not, this will always execute it. So if you want to experiment a bit of that, what happens when error occurs? So let's say f.write, and if I just say raise, just to raise an error, and if we go into exit, this particular line will be executed. So let's do that. So see, we entered, we exited. So because it says inside exit, that means it executed everything inside the exit, even though it errored out. Even though it raised an error, still it kind of like went inside this exit code and clear everything up. So that is why it is very important, because let's say if you had, let's look at this example. Let's remove this, all this thing. You have this f.write, you have f. Let's say you just say try this, and except you say, print error. So here we'll print whether file was closed or not. Raise. Now if I do this, see, the error occurred here. I raised here, so error occurred, it went here, and my file remained open here. So this is the kind of error that can bring you into trouble. But because as you saw here in this example, even though the error occurred, we successfully went to exit and close the resources. So that is where it is very, very much important. This is for the file. This can happen with database. This can happen with internet access. This can happen with so many other things that you want to take care of and you don't want to get into mess of. So now that demo is done, let's go back and see the rest of our presentation. Where is that? Here. Okay, sorry. Okay, here. So what are the very good use case of context manager? So if you guys have written unit test, a lot of time in the unit test, we have this thing called setup and tear down, which is basically, set certain things up, tear certain things down, and then run all the tests. So you can use context manager to do all these things. Of course, file open and close. Same for the threads. If you are opening the thread pool, if you run out of the thread, that may cause a problem. So you want to like make sure that every time you open the thread pool, you close the pool. So that can happen. Database connection, the example that I gave you, my own war story, and finally, the time to execute the code. So that the example that we just saw recently. So all these are good use cases for context manager. And at the end, so what you want to say that, context manager is of course better way to handle resources. It is much more clear, it's much more readable, it is less error prone, because we saw that when you're writing context manager, you are intentionally making sure that nothing can go wrong. If you are relying on try and catch, you might make a mistake, and you might leave the connection open even though you have done all this try and catch and everything. You say that, hey, my code is perfect, everything is between try and error, and I'm making sure all of that, but things can go wrong, and you don't know, like your try block may be too much huge that you forget that, hey, in the exception somewhere in my try block I open up some kind of connections. Even it was not like direct, in the try method I called some method, and that other method actually opened the connection. So I really didn't know that inside the try some kind of connection was open. And and if you are following this manually opening and closing kind of scenario, then it will be really troublesome. So context manager is always better way to do that. And of course, it improves reliability, because you don't want to wrap around your code every time try and catch. It's much more cleaner when you say with, error handling, and then you write your code. So it's much more easy to read and understand and work with that. So, and something else, if you guys want to look at, there are some more context managers with complex example. You can create two context manager and use at the same time. Let's say you want to use error context manager and logging context manager at the same time on same particular code block. You can do all those kind of things. There's a context decorator. So there is another thing that you can use. So there are couple of more stuff that you can look into it if you want to go much more deeper into context manager. And these are some references. So thank you very much. I think this is the first time ever that we finished our presentation in time. I intentionally kept it short, and I think that we were able to finish in time. And okay, so once again, I would like you guys to ask if you guys want to do some kind of presentation Amit, you told me that you are interested, so let's talk sometime and look through this. All the resources will be available, and if you guys, hey Sadaf, if you also have some kind of topic that you guys want me to cover, you guys might be interested in, just let me know. I will cover that topic into any of the upcoming meetups that I set up.
Sounds good.
Okay.
Cool. Thank you, Nishant. Have a good one.
Okay. Good night, guys.
Bye.
Bye, Amit. Bye, Sadaf.